Remember when big tech used to be, well, big? Giant computers, cell phones? We've come a long way. The materials that go into things we use every day have gotten smaller, much smaller, and it's now at the point where you need a microscope to see some of them. It's called nanoscience.
So we can't see most of what we work on.
Kristen Dellinger and other researchers are manipulating materials right down to the atomic scale. It's part of a $1.5 billion partnership between the North Carolina A&T, the University of North Carolina Greensboro, and the Department of Defense to keep soldiers safe. The project is called ICONS. But then there's also the issue of clean water.
We create sensors that basically allow us to determine, for example, if water is contaminated with arsenic or lead or mercury. And so at the nanoscale, we're able to create things that interact with these ions that are extremely small.
Soldier health and safety on the battlefield is a primary focus of the partnership. And while it seems pretty basic, water quality is a major focus. The government spends a lot of time and energy moving bottled water around the world to help keep soldiers hydrated. That's because troops are often deployed in areas where they don't have access to clean water, and that puts them at risk of getting waterborne diseases like dysentery. When bottled water isn't an option, soldiers currently use mobile biometric testing like this to make sure water is safe. They tend to be about the size of a small suitcase. Researchers hope to make the solutions a lot smaller and more portable.
One of the big projects that they've been working on is enhanced filtration systems, and to ensure the effectiveness of those filtration systems, they need accurate sensors to be able to tell someone on the battlefield in a very critical situation, for example, and very quickly if their water is safe to drink.
The goal is to scale the test down to the size and simplicity of a pregnancy test. The soldier would simply dip a tool into the water for a reading. The question is, how do you design a sensor to detect harmful contaminants? Researchers are focusing on the biochemical makeup of cells that will be present in any test. Cells are made of nanoparticles, and those nanoparticles emit different colors because they reflect and absorb specific wavelengths of visible light.
So what we have here is a software system that is attached to our microscopy. So what it does is allows us to look at very small particles such as cells using color. So other microscopy can allow you to do that using black and white, but over here the advantage is you can use color to distinguish between even different components within those particles.
Once a method to detect what's in the water is found, next comes building something that will administer the test. We'll call it a proof of concept that requires specialized manufacturing.
We print it by using 3D printing machines. So it prints the device by using something like rubber material. And so it is elastic and it can make the flow happens.
And the proof is in the rubber. The technical name for this is a microfluidic chip. See the channels that zigzag through the center? That's where the microscopic sensors that detect the contaminants are located. Researchers are already looking at other applications for this type of technology. Similar size and styled chips could be made from ultra-thin graphene and woven into a soldier's uniform. Those sensors could be used to detect dangerous airborne particles. But for now, the focus is on clean water.
The water component is really important to us, not only from the perspective of applications to the Department of Defense, but also from a humanitarian perspective. So we also have interest in developing sensors that can be deployed in relief areas after hurricanes, in third world countries that have needs to test water quality very quickly using low-cost sensors.
Thanks for watching. If you enjoy science stories like this, like and subscribe for more.